in this tutorial we are learning about matching mathematical expressions using logic programming. So in our previous tutorials we have seen that what is logic programming, and we have understood the concept of logic programming. And now we are seeing an example, an implementation of logic programming. So that is your matching mathematical expressions. Now you know very well that what are mathematical expressions. We are basically dealing with different mathematical expressions daily. So what we are doing here, we are matching those expressions. We are comparing different mathematical expressions and we are seeing the difference between them using logic programming. So before we start logic programming in Python, we need to install a couple of packages. So the package logpy is a Python package that enables logic programming in Python. So first you have to install that logpy package in your Python idle so that you can use logic programming in Python. So for installing that package, you can use the command pip3 install logpy. There is one more package related to this, that is your canren, K-A-N-R-E-N, that is your canren package. You can use either logpy package or you can use canren package. Both are used for logic programming. If you get an error during the installation process for logpy, you can install from source at this link. See this link at github.com logpy. So on that link you can find your package, logpy package, to install. We encounter different mathematical operations all the time, and here we are using logic programming to compare those expressions and finding out our unknown values. So let's see in Python how we can do this. So let's see a program for expression matching mathematical expressions in Python. So first step is to import package. We have to import few modules here. So what we have imported here, we have import canren. You can use also logpy module, but we have imported here canren module, and from that module you have imported run, var and fact, which we will use. And this is your another module, that is socom, that is as LA is representing that module. Now first step is your defining mathematical operations which we are using here, that is your addition and multiplication. So basically we have used here add and mul variable for representing these two mathematical operations. Now next we are declaring that these operations are commutative. So for that we are using the fact function, and we are using la.commutative as multiplication operation. Then these two are commutative as well as associative. So we have declared those operations. Next we are defining our variables. So basically we have three variables here, a, b and c. So we have used here var function for representing a, b and c as a variable. Next, our expression which we have to match. So this is your original expression, and these are the three different expressions which are actually denoting that expression. These are same, these expressions are same because their output is same, and we have to just compare those expressions with that original expression. Now see, this is the first expression, 3 into minus 2 plus 1 plus 2 into 3 into minus 1. Next expression 1 is what? Your 1 plus 2a into b plus 3 into c. So a, b and c are three variables, and we are not using any number, we are using a, b and c. And then finally we will compare that expression with our original expression when we will compute those variables by comparison. So in this way we are matching those expressions, and that's why it is an example of matching mathematical expression. Now see, this is your expression 2, c into 3 plus b into 2 into a plus 1. This is the same as this expression, but this a, b and c positions are changed here. Expression 3 is also the same expression, but here again a, b and c positions are changed. Now we have to generate expression. So we have used here add and mul. These are representing your operations. So we have specified all the four expressions as here. Next, we are printing our final output, so we are using run function for that. Now this method takes the input argument and run the expression. Now what are the arguments? The first argument is the number of values, second argument is a variable, and the third argument is a function. So third argument will be our function. Here we have used here EQSOCOM. This is used for comparing expression. So we have these are the three different statements. We are running those statements, and we have used here expression 1, and we are comparing that expression with our original expression, then expression 2, and then expression 3. Okay, so let's run this program. Now see, this is the output: 3, 1, -1 and -2. So what are these? These are actually representing the values of A, B and C. Here A is 3, B is -1 and C is -2. After comparing these expression with original. And third, it is representing none because the structure is different. Since the structure is different for expression 3, so it is representing your none. So it is mathematically same, but it is structurally different, and that's why the final output is representing none. So that was your program in Python. You can use your different example and similarly match those expression with another expression. Okay.